Yeah, about balancing batteries. And welcome to the second part of the Twike series, in which we are going to take a look at the current battery situation, as well as a general overview about all of the quirks and features of the Twike. But more on that later. These are actually all broken, but these battery packs down here are hopefully not broken. I exchanged some batteries out of these, the broken ones I used earlier, with batteries from these battery packs down here, which come from this Twike without batteries anymore. So you see, I had to make some sacrifices. These batteries, as I told you in the last video, don't actually have a balancing system. They only rely on passive balancing once a year through a mechanic. They have these balancing ports. One of them is connected on the left, and I bought some connectors. It took me like 3 hours to find the right connector online, and now I'm balancing them myself. I'm probably going to work on these batteries for a longer time, as you might expect when you see this mess right here. So it's best to not store the batteries at their highest capacity, or the lowest capacity of course, because they have self-discharge, but you want to store them at maybe 60% or something like that. It depends on the battery chemistry. For lithium iron phosphate batteries, 3.3 volts is a safe battery voltage to store them at. And yeah, let's get you an overview about the Twike electronics and how everything is working together. From the batteries, almost 400 volts go to this. This is a basically aftermarket drive motor vehicle controller that manages all the power distribution throughout the Twike and gets its low voltage from this 14 volt step-down converter, and has a main contactor switch that can disconnect or connect to turn on the vehicle, and over here has the battery boards and relays and turn indicator relays and stuff. So all the output and input points for the different parts of the vehicle. And then down below we have the inverter and motor driver, which gives the corresponding AC voltage, so converts it from DC to AC and drives the motor, which is located down here below. We'll look at that another time for sure. But this one has custom firmware on it. It's not really hackable or also not produced anymore as far as I know. It runs also the display. So this little display is basically all the interface you have. You have a speedometer, which is very basic, just a few numbers with LEDs behind it, then a few light switches, heater, and you steer by turning this. So this is connected to the front wheel directly, and you have like a push button for going forward in 2 steps. You have one acceleration, so with a set amount of amperage, and then you can press it fully and it goes to a higher acceleration with more amperage for the motor. Same below for braking, like electronic braking, regen, and then you can also just press it shortly and have a cruise control enabled. Also turning indicators, and that's it. Then there are a few more small things, like this knob here right here, which is your drive selection indicator. You have forward with pedals enabled, then you have only forward, and you have back. Over here you have the charging port. It has like a plug to plug it in, so the system knows that the cable isn't connected to a wall outlet, and also automatically starts the charging mode when this is unplugged and you can't drive anymore. Then on the front we have pedals, of course. We have a brake switch for the brake lights and a hydraulic cylinder for the braking system, which you activate by turning the wheels backward. Then you have a hydraulic dampener right here with a dial, so you can adjust the steering force required to turn the wheel. And you got some hair fans, actually hair fans, yes. They were quite hacky back then. And these are, of course, actually AC fans. However, they don't care because it's only a heating element and fan inside, and they run it directly with the battery, which is crazy, but it works. Right here, windshield wiper motor from a Jeep or something, I think, which I read would be very unreliable, but luckily for me, it hasn't broken down yet. Probably the only thing that hasn't broken down. Yeah, and then you have these small, like a motorbike tire, and this for braking. Old lights, of course, not even LEDs, although the previous owner replaced the backlights with some newer ones with LED. Then you have a very simple strap to keep you in place, and all aluminum and plastic construction of the Twike itself. The floor, well, there isn't much more to the rest of the vehicle. It's all a special kind of plastic, just very thin, maybe 3 millimeters, that is glued to the aluminum frame, space frame, or whatever they call it, which is all connected to the tubes that run one time through the vehicle. In the back, we have, of course, the two back wheels, and in this compartment the battery, of course, and in front of it down below is the motor, which I'm trying to get to, but haven't managed to do so yet. Why, you might ask? There are lots of screws and holes like this one that are completely rusted, and if you have ever tried to take out a screw from a hole that was not put in with screw grease and rusted, then you know you have no freaking chance. Yeah, I guess that's basically all for that video. And in the next video, I'm actually going to look at the isolation tester over here, there, and figure out whether I'm actually having to remove the motor or some other electronics part, but I'm quite sure. So yeah, I think that's all for this video. Let me know in the comments below what you think, what you wanted to see and I didn't show you. Please feel free, and I hope to come back to them in the next video. And I really look forward to reading your comments, and hope to see you in the next video once again. Bye!